Hello and welcome to That Fabric Guy. My name is Basland and I'll be teaching about Microsoft Fabric every week here on YouTube. And today you're looking at a video titled Asset Transactions in Delta. And this is part of my All About Delta series in which I record a bunch of videos in a few minutes each, going through the different properties of Delta tables that are powering your Microsoft Fabric lakehouses. So the magic that you get with Delta is mainly in the Delta log. We already went over that in a previous video. And the secret sauce that you get isn't just the Parquet storage. It is the log and the logic that is handling all the transactions that we're doing and the fact that these transactions are following the ACID acronym. You can have multiple jobs writing data, you can have jobs reading data, and all at the same time. That will just work and you will get consistent data that just works. It is not an art, it's more of a science, and today we're going to look at how that science actually works. So all about ACID. So what the slide says here basically is Delta Lake provide ACID transaction guarantees between reads and writes. And what that means is the following. ACID is an acronym and it stands for atomicity, consistency, isolation, and durability. The atomicity part of ACID means that it is a all or nothing write. You cannot put half a transaction in a Delta table. So if you're writing 100 rows of data into your table and halfway through the process fails, it is rolled back. The transaction is not being committed. It's not the case that you get 50 rows or 51 rows. You get 0 rows. And only when the transaction completes, it is being put in the transaction log and you get these 100 rows that are being written. Consistency means that the table rules are upheld. There are checks on schemas, on constraints, on metadata, and if your write process or update process does not adhere to these rules, your transaction will not go through. The isolation part means that readers will not see the messy in-between transaction states. The transaction is isolated, and that means that the transaction is either done or not done, and you can only read transactions that are done. So even though you are writing 100 rows, you will never find a way to read part of those 100 rows. You can simply not do it. You either read the 100 rows or you don't. And then the last part, the D stands for durability. Once a transaction is committed, it sticks inside the Delta table. And that means that if you start looking at the way that the Delta table is built up, I've made a video prior in the same series about the anatomy of a Delta table. If you look at how the Parquet files and the transaction log are built up, you will see that you put 100 rows in, you take them out, but this transaction sticks, it is durable. You can find in your history that once upon a time, these 100 rows were actually in your table. Now about this Delta log. When we write data into a Delta table, and when we update data into a Delta table, we are writing new Parquet files. We commit then a transaction to the Delta log folder. It's the _delta_log to be precise. Readers will then, after the commit, they will see a new version of the Delta table. So we had version 1 and now we have version 2. Version 2 contains this new commit. And Delta uses a very optimistic concurrency control. That means that writers will assume that they can always proceed writing data into Delta, and Delta then checks for conflicts at the commit time. And that means that there is some key behavior that we need to understand. If we have multiple processes writing data into Delta, they can attempt to do these updates or writes or inserts. Only one can successfully commit into a new version. So let's say we have version 1 of the Delta table and 2 processes are trying to create version 2. That cannot happen. Conflicting writes are rejected or retried, and that means that we're not just silently corrupting the table. No, we get a table where commits are happening one after another, and therefore our history of commits is preserved. This is really important for readers of this data, because as a reader we get a very consistent snapshot view of the state of our data at the time of the commit. We always see a stable table state, and even while writes are happening, we get a very isolated and locked down version of the data. So a process can take maybe, I don't know, minutes to write data into a table, or hours, or I have no idea. But during write, we see the previous version of the table. Once the write is completed and the transaction is committed to the Delta log, only then does the reader see that new version of the table. Now imagine this, we have two jobs running on Fabric. Job A or pipeline A is ingesting new data every minute. It is just trickling in like that. Then job B is running an optimize or maintenance routine, and meanwhile an analyst is using a SQL query or a Spark notebook to read data out of Delta tables. Now with Delta, it is not the case that our analyst will see half of A and half of transaction B. No, we will see a very clean snapshot that is either pre-A and pre-B, or post-A, pre-B, or post-B. That makes sense, right? Because only once the transaction is fully committed, we can see it in our as a reader on Delta. So a quick recap on the ACID transactions. The Delta transaction log is what makes a file, like a Parquet file, behave like a real table. It records changes as version commits, and we've seen that in a prior video. We use checkpoints for speed. We've also seen those in the Anatomy of a Delta table video. We enable ACID guarantees with optimistic concurrency and snapshot for reads. In the next episode, we now know that writing is safe, so we are going to look at how Delta will keep your table from turning into schema soup. Schema enforcement is a really important part of a Delta table, and schema evolution is something that we need to think about as data engineers working on Microsoft Fabric. These guardrails will stop you from ruining your day, so let's definitely check our next video, and please do so, like this video, subscribe to my channel, and I will keep you posted when the next video drops. See you next time.